All right, welcome to your Chapter 3 lecture video in C++, CIS251 online. Chapter 3 deals mostly with variables and constants. It doesn't get into a lot of syntax, but we're going to take our project, which I will give you a project video for Project 3, and we're going to take it a little bit further than what they're asking for in the book by having you actually create a working program based on the algorithm that I've provided already in Blackboard. So you'll need to be doing this before you start coding for every project, as you learned in your CIS150 class if you had an opportunity to take that. So let's talk about variables and constants. As you can see here, I have a little PowerPoint one-page thing that I've done. Variables and constants are names selected by the programmer. Now there are certain naming conventions that you have to follow. And again, this is a review for most of you, but if you haven't had CIS 150, then you probably don't know what camel case naming is or Pascal notation. And what that means is for variables, constants are different, but for variables, if it's one word, it's all lowercase. You cannot have spaces, special characters, anything like that. I mean, you'll get a syntax error if you try that. If it's more than one word, every subsequent word, like if it's 3 words, the first word is lowercase, the second word starts with an uppercase, and then everything's lowercase, and then the third word starts with an uppercase and everything's lowercase. And I'll show you that as we get into the program. But so that's the naming convention, and they'll probably get into that. If not this chapter, then another one. I feel like they'll talk about it rather shortly. But I want you to get in the habit of doing that. When we get into Project 3, you'll see. Names are selected by the programmer for both variables and constants. Now constants are always uppercase, and to imply space, which you can't have in either one, you can use an underscore character for that, but you can't have spaces. These ultimately map to memory locations via the compiler. When it loads, when the operating system loads your exe into memory, then it will sort of take that on further and help you out with allocating all that memory. These allow access to those memory locations by using the name. Okay, so rather than having to actually know the hexadecimal location of that memory location in RAM, which is what we used to have to do with assembler, use hex dumps to debug your programs. Real pain in the rear end. Now all you have to have is the name. Everything, the compiler and the operating system take care of everything else. So when you use the name, you actually have access to that memory location, which means you can put data in, pull data out for variables. For constants, you only have one. That's a one-time deal, and after that, it cannot be altered. But variables, as the name implies, can be. And these locations are created and reserved to store specific type of data. It could be an integer, a float, a double, a char, boolean, and other strings, other things. Both variables and constants are created and behave the same way, with the seminal difference being that the data stored in a variable location can change, while those stored at a constant location, once initialized, cannot change. All right, so there's that. Now let's go to, I have a little application up here. It's just an empty application, just like you did when you did your attendance project. As you can see, I pasted the code from the student resources, little stub code that I have out there for you. So let's talk about how you declare a variable or memory location. You first have to give it a data type. All right. So I'm going to go here and just use an integer. Int is the keyword for integer, so that's the first thing. All right. Then you got to give it a name. I'm going to call this my age, just for grins. All right. Then you have to assign, initialize it with the default something to wipe that memory out, because there can be, and usually are, data from other runs of other applications or whatever, operating system maintenance. So int age, assignment, some value. Well, if it's an integer, you use a 0 typically, unless you happen to know exactly what that value is, and most of the time you don't. Now this is called a variable declaration. You can do it in 2 steps, but it's just as easy to do it in 1. I could do int my age, semicolon, and then my age assignment 0, but I'm going to go ahead and do it this way. Notice every line terminates with a semicolon. All right, so when the compiler sees this declaration, it gets to this line. It says, okay, I need a memory location, according to what the programmer's doing here, that will hold a data type of integer, which is usually 4 bytes of memory. And then I'm going to point, once that is assigned to me, I'm going to point this name to that memory location so that if I use my age, then I'm actually pointing to some hexadecimal address, some location in memory. Now it sees this assignment operator. I know it looks like an equal sign, and it is an equal character. But in this context, it's not a test for equality. It is an assignment. And this is a primer for most of you, going back, refresher to 150. The rule for an assignment is you take what's on the right side of this assignment operator, and there can only be one value over there. If there's like 6 plus 3, it's going to do the math. Whatever it has to do to get down to one value. It can be true or false. It can be a number, it can be a string, whatever. But it's got to be only one value over here. So it's going to take that value and stick it in the memory location, wherever that happens to be, pointed to by the name on the left. That's the rule. At that point, there is a 0 at the memory location pointed to by my age. Now this is a variable, okay? I can do a variable of another type. I can do a double, which has a decimal. It's a number with a decimal component. If I need to initialize that to 0, it has to be 0.0 semicolon. Oop, sorry, forgot to delete that. So it's double, and then I'll say my pay. Okay, so my pay would be like, depends on how much you make, but it could be like $1,356.33. Okay, and that's why you have to use a double. Can't use an integer because it doesn't have a decimal component to it. Let's do, what next? A Boolean. Bool. That's a true or false, yes or no, on off, right? So in this case it's true or false. I'm going to call it flag. All right, I'm going to set it equal to true. You have to, in my class especially, all my classes, you have to give default values to wipe those memory locations out. That's just something I require. There's no sense in having garbage in there when you can just do it one little extra step. Okay, so notice how I camel cased these. Flag is one word, so it's all lowercase. My age is 2 words. The first word is all lowercase, and every subsequent word starts with an uppercase for the first letter. Same thing with my pay. So that's basically variables. Now let's look at constants. Constants work the same way, except they're preceded with keyword const, then the data type, then the name, and then some variable value, some initializer. Now, once this is done, my age cannot change. Now, here's another issue. The naming for constants is different. It's all uppercase, and I like to separate words with an underscore just so it's easier to read. I mean, it's easier to read than this, right? So it implies that that's 2 words, and I don't violate the syntax rules by using a space. So my age assignment 0. Of course, it could be 50, whatever it is. Now, typically, this would be something you just don't want the program to accidentally change. Whatever, it could be a tax rate, whatever it happens to be. So essentially, the creation of these are the same. The keyword, the definition is a little bit different. Excuse me, the declaration is a little bit different because it has this const keyword. The naming is different, all right, and also the obvious fact that constants don't change and variables can and usually do. Okay, that's enough for this lecture because it's a very short chapter. I'm going to go ahead and do the video now and post it for Project 3. So I will see you then. Have a good day.